Hello students, welcome back. We did some motivation example and some theory. Now it's time to do some real examples. Okay. How about some problem like this? Okay, alright. So what did he discuss? In the theory part, we discussed basically this. So capital Y of S is gonna be something over characteristic polynomial, and then decompose it by partial fraction. So something, I don't know, whatever that something is, and to tell the truth, I don't care that much about that. It's gonna be something we'll have to determine anyway. And the denominator, of course, is important. S squared plus 3s minus 1. Did I do this right? Coming from here. And then, therefore, this is R of S over, let's see, 4s minus 1 s plus 1, is that it? Plus 4 minus 1, I guess that's it. So we'll have to have C1 1 over 4s minus 1 plus C2 over s plus 1. Looks like this is going to be the decomposition by partial fraction. Therefore, what is phi of t? It's going to be some constant related to C1 in this particular case. And then this is e to the, and when is this thing become 0? 1/4 t. Let's expand the font a little bit. And then k2 e to the negative 1t. Is that clear here? Here, the 0 of the denominator is 1/4. So yeah, that's what I'm going to get. And here, the denominator is negative 1. So that's what I'm going to get. That's the solution. Was it easy? The beauty of all this is I don't have to know what R of S is. I don't have to know. I don't even have to know what C1 and C2 are. You just use the theory of decomposition by partial fraction, not actually decomposing, okay? If you can factor, you can easily handle this. Okay, how about the next problem here? Oh, this one is a little bit harder in a sense that we have higher order, but that should not be too much of a problem. So capital Y should be R of S over Q of S, and R of S, which I don't care, and I don't really have to know, and Q of S is 4s to the what power? What power? 4th power plus 3s to the what power? 2nd power minus 1 coming from here. Similar to previous problem, but the factorization will be a little bit different. 4s squared minus 1 s squared plus 1. That's it, isn't it? Plus 4 minus 1, yeah, that's it. So can you factor further? How to factor denominator? I mean, how to factor the first factor of the denominator? 2s plus 1, 2s minus 1. How about the other one? I could do s plus I, s minus I. I could do it like this, and personally I prefer complex numbers, so I'd like to do this, but let's follow a textbook all this way. Just keep it as s squared plus 1 squared. And then this can be decomposed like this. Some constant over the first factor, 2s plus 1. And another constant over 2s minus 1. And then we need quadratic irreducible here. So we need C3ts plus C4 over s squared plus 1 squared. All good? Okay, all right. And then let's go ahead and find out the Laplace inversion. What's the first one? Denominator hits 0 at s equal negative 1/2, right? So some constant k1 e to the what power? Negative 1/2 power. Did I do this right? This time, denominator hits 0 at what? Positive 1/2 t. Okay, how about this one? I remember this sine and cosine. Let's see. By the way, if you didn't remember the previous, you could have opened this one. E to the at is one over there. Sine and cosine, s over s squared plus b squared, b over s squared plus b squared. So we need s part, that's for cosine, and then we have s squared plus 1 squared, so it's cosine of 1. Oops, I lost my notebook. Okay, so this is gonna be k3 cosine of 1t. And then sine of 1t. I guess that's it. Oh, yeah, did I do this right? Okay, oh, never mind. Okay, all right. Here, for some strange reason, I decided to go really strict on these constants here, but it's not really necessary. Excuse me, and this is better. Whatever constant is going to be determined anyway, right? I don't have to track down what these constants are, and I don't have to track down what R of S is. All I care about is actual solution, and then here I have these coefficient, and that's about it. And when I have to determine these coefficients, let's just determine these coefficients. What relation I have this with that is not really necessary. For that reason, many people just use the same constant, just like that. Even though these constants here and there do not correspond, they are not the same, but that's okay. I mean, it's arbitrary anyway. But here, I just took a little bit better approach and changed c into k. So it's a constant, arbitrary constant, integral constant anyway, but to be determined. They don't have to be the same. Oh, by the way, there's mathematical command there. Okay, k1 e to 1/2 power, k2 e to negative 1/2. Okay, define like this, and then simplify this expression. Fourth derivative of y, and then 3 times second derivative of y minus y. Is it really 0? Yeah, of course it's 0. So the theory here, the theory here may have been difficult to follow, starting from the general setting, and then input derivative rule, which gives rise to characteristic polynomial and the polynomial of lesser degree, and then getting the rational function, and then decomposition by partial fraction. The theory may have been hard, but actual implementation, that's not supposed to be hard. How about this problem? As usual, this is R of S over Q of S. And R of S is something nobody cares. And Q of S is going to be given by, this. Okay, 4s to the 5th power minus 7s to the minus 7s to the 3rd power plus 65s squared minus 61s plus 15, and you have to decompose this by partial fraction, or you'll have to factor this. How would you do that? How would you like to factor this? Any idea? That's how I'd like to ask you to use appropriate mathematical command for that. Now, if you try to use factor theorem, remainder theorem, and whatnot, fact by grouping or whatnot to factor this, go ahead. I'm not going to stop you. But if you're going to live in 21st century, and then if you're going to claim that you majored in mathematics in 21st century setting, then you have to claim appropriate proficiency in computer algebra system. Otherwise, you're not going to be considered as an up-to-date mathematician. As for some mathematical commands like this, those are necessity. It doesn't have to be Mathematica. It can be Maple or Magma or MATLAB or whatever. It's just that the commands I know are Mathematica, and there's simple commands like this, just one-line commands, are mostly available in Wolfram Alpha for free. So there's another reason that you should be preferring for that. So anyway, that's the factorization, and let me expand the font a little bit. So we have linear factor, so C1 over S plus 3, okay. C2 over, here's another linear factor, 2S minus 1, and C3, and then I'm going to use 2S minus 1 again, because this goes to the 2nd power. And C4, this should be C3, S plus C5 over S squared minus 2S plus 5, and this may need a little bit of work, because let me open up the reference. You need complete square plus another square. You see, you have to use a complete square. So this one needs a little bit more work. So instead of writing as S squared minus 2S plus 5, let me write it as plus 1 plus 4 like this. And please note that this is complete square, and then this is 2 square. Okay. Therefore, y of t is from the first function, what do I get? K1 e to the negative 3t. By this time, I expect some proficiency from students. So whenever you see 1 over s minus a, you should be looking up the table. That should be just coming right away. Next, a2 e to the, when do we have 0 in denominator? 1/2 t. Okay. a3, this time this is square, so how to handle it? T times exponential of same characteristic value, and then k4. Let's see, this is complete square, s minus 1 squared, so e to the 1t times cosine of, you know what, let me rewrite this thing. Oh, never mind, let's just see. I'm using I can use copy and pasting, so there's no reason for me to skip steps. Okay, so this is 2 squared, so cosine of 2t plus k5 e to the t power sine of 2t. So this is 2 squared, so we have cosine of 2t, sine of 2t, and then minus 1, so we have e to the 1t, e to the 1t there. Go to this reference here, or you can go to our textbook, page 123 if I remember correctly, and then check those out. S minus a squared plus b squared form, sine of at times, e to the at times sine of bt, and similar like those. Oops, I did it again. So that's the solution. Let's see, is that what I have over here? Factored, yeah, like this, and then I got all that, and then we got this, and then yes. Again, don't pay too much attention to these. I don't have to retrieve those C1, C2, and so on. So I shouldn't have done these. Well, here in my mathematical command, I'm using K1, K2, K3, and so on. Obviously, I did better job here in mathematical coding here in terms of, easiness to recognize. So, of course, that's correct. So this kind of problem would have been a humongous challenge if you have to do just paper and pencil problem. But if you know the theory of the Laplace transform, and then use computer algebra system to do some dirty algebra computation, it's not too bad. Not bad at all. Just 2 line, maybe 3 line. It's not bad at all. Okay, all right, so much for the example problem. And then we're going to talk about non-homogeneous system in a separate video. Thanks.